All right, so now we're on to section 11.1, which is about functions of several variables. And we're coming up on the last bit of groundwork we have to lay before we can start really doing calculus, so hang in there, we're almost there. When we talk about functions of several variables, we're mostly going to focus on a function of two variables. Just because we tend to think in 3D, and this is what ends up being 3D. And what a function of two variables is going to be is just some rule that we denote by f of xy that assigns a unique value z to that f of xy for every xy in the domain of the function. And so we've talked about this idea before of how you're used to doing the vertical line test for functions of just one variable in the xy plane. And if you kind of extend that to 3D, you have the idea that every xy coordinate you have should assign you to a different value, z. And so an example of this, there's a function. Every location you pick, you could go up and know the value z that's assigned to by this function. And you've been working a lot with functions of several variables, just we haven't called them that. But when we learned about planes, we had like 0 equals x minus 1 plus 2 times y minus 2 minus 3 times z plus 1, I guess. And you could always rewrite that as z equal to 1/3 x minus 1. Oh, that's a bad one. We'll fix it. Plus 2/3 y minus 2 minus 1. I just moved z over to the other side and then, isolated it. But that right there is a function that depends on x and y only. And you could go ahead and check anytime you pick a number for x and pick a number for y, you can calculate this and it's always going to give you the same answer, so you know that it is a function. And some of the surfaces we've drawn have also been functions, but some haven't been. So a lot of these ones that had z squared in them would have sort of a top and bottom part, depending on whether you took z equal to plus or z equal to minus of whatever you solved for. So either of these alone is a function. Because as I kind of showed before, any coordinate you visit, there's only one value, z, that matches that xy coordinate. But the entire surface that I've drawn here is not a function. If I go to this value xy, there's my y, there's my x, then there's kind of two different values z you can imagine, depending on whether I'm looking at the top or bottom part of my kind of bowl shape here. And I'd like to talk to you about graphing functions of two variables using something called level curves. And what I'm going to do is I'm going to write the steps first and then show you what a level curve looks like. And then we'll do an example where we actually graph these level curves. So what you're going to do is you're going to start by setting your function f of xy equal to c for some number c. And then you can go ahead and solve for y equal to a bunch of stuff that maybe depends on x in there. We'll still have c in it somehow. So I'll just write those right there. And you can graph that in the xy plane. You're really good at this point in your career, taking something that's y equal to a bunch of stuff and plotting it or guessing what the plot looks like or asking a computer to do it for you. And you just repeat that for many values of c. And what this is going to do is it's going to generate slices of the surface z equal to f of xy. So kind of going back to our maybe example of a plane. So there's my xyz coordinates, and here's a plane. I'm just going to go ahead and say it's z equal to x plus y because that's easier than the random mess of algebra I had earlier. That's a surface of f of xy. Actually, let me go ahead and write. We're thinking f of xy equals x plus y. If I go ahead and do these steps to generate my level curves, they're going to look like y is equal to c minus x. Oops. Let's go ahead and give them a color. For a bunch of different values c. There's c equals 1, c equals 2, c equals 3. How I got that will make sense when we do our example. I just wanted to show you real quick so you have a visualization. And those slices correspond to different heights. This would be 3, 2, and 1 that z reach, and you just kind of like take a big cut out of this piece of paper. And if we actually want to do this process, we can do it for, let's see, f of xy equal to x squared plus y squared. And real quick, we can just remind ourselves that the surface is going to look like, here's x and y. And if I want to say z is equal to x squared plus y squared, then this is just going to look kind of like that right there. Google wants me to learn. All right, but if I want to actually generate the level curves, I can follow these steps I wrote just now. So I'm just going to pick random number c and set f of xy equal to c. So I'm going to say, okay, I want c equal 1. Then I say 1 equals f of xy. That is 1 is equal to x squared plus y squared. And then I told you, you solve y equal to, 1 minus x squared plus or minus. If that's what you got to do, then you'll know that like the plus part is here. Actually, I should go smaller. And I should pick colors. So the plus part is here. The minus part is here. But really, that's just a circle with radius 1. mark that with a little dot right there. And it's okay if you know that's a circle. You don't have to solve for y. Then I say, okay, that went fine. I guess I'll pick c equals 4. 4 equals x squared plus y squared. That tells me that's 2 squared equal x squared plus y squared. And so now I'm going to have a circle with radius 2. We're just going to pretend I can draw centered circles for a little bit. And I will mark that with a square shape for anyone who can't see colors. And we'll do one more. C equals 9. 9 is equal to x squared plus y squared. So 3 squared is equal to x squared plus y squared. And so here's my radius 3 circle. Wow, that's super laggy. I'm going to blame that for why this circle is worse than all the rest. Okay. Mark it with a little star for anyone who can't see that different color. But those give us our level curves. And if somebody asked you to plot the level curves, then you could go ahead and stop right there. Just so that we're all on the same page about what a level curve actually is, though, I'd just like to show you on this picture of z equals x squared plus y squared, that what we're actually doing is we're taking slices. So right there would be at the height z equals 1. Oops. Forgot to do my little mark. Next up would be at the height z equals 9. Here we go. And oh, sorry, my next one was z equals 4. I skipped. I'll just correct that, and then we'll not plot the 9 one because this is getting really buggy. But you can imagine that the 1, 4 z equals 9 would just go higher up, be at the height z equals 9, and then be this bigger circle that we drew before. So that's what a level curve is and how to generate it.